Hi, this is Cody Hennickson, and today we're going to be looking at Java 2D arrays, doing some note review for that so we can get you guys prepared to understand better how to use them and keep on understanding how to use 2D arrays within Java itself. So the first thing we want to take a look at is the concept first, that Java deals with arrays as an array of arrays. So when you're dealing with a 2D array, what you really have is you have one array where every entry in that array is actually a whole other array. And so that's why with Java we have only the first column itself on a 2D array is accessible on its own, because each of those spots from sub 0 to sub length minus 1 of that array are actually containing the rows of that 2D array. And we always want to make sure that in Java, although it's not required, but as a formal structure, we want to make sure we always specify our rows first, then columns on our 2D array. The reason being is many other languages actually require rows first for their structure for either memory allocation purposes or just the way they actually reference it internally. And so we're going to keep that same process up on our Java 2D arrays as well. So we're going to always specify our rows first, then columns when we define a 2D array here in class. Arrays, when we talk about in Java how they're hipster, arrays that are 2D are still hipster in Java. Again, we have no methods outside of what are provided by default by object. And again, those methods we don't use 90% of the time on what we're comparing and using with on this. And the big thing again on that is we have that single public data member .length to find out the bigness. Now, talking about .length, we wanted to actually look at how we're going to use .length on a 2D array. We have two different ways we're going to use it. On the first one, with the array name .length, that will give us the number of rows in that array. So we count that by doing the name of the array, whatever it is, .length, tells us the number of rows. To get the number of columns, we have two separate ways of accessing that information. The standard way that we'll be using, since in class we'll only be using what are called rectangular arrays, or arrays that have the same number of columns all the way down, we simply will just use the default level of saying array name sub 0.length, which gives us the number of columns for the first row. And since the first row has the same number of columns as every other row, that repeats all the way down. As you proceed with computer science, however, you may often see that not all arrays are in fact rectangular. They are what are called a sparse array, or where there are actual gaps in size. You can have one row with one column, one row with 8 columns, one row with 5,000 columns, a row with 2 columns, row with 3 columns, etc. And so in that case, if we know that we're dealing with a sparse array, rather than referring to the number of columns as sub 0.length, it is more appropriate in that case to use sub row.length, because that will give you the number of columns for that specific row. You can use either of them on a rectangular array. I just want to make sure that we have a standard way of accessing that information. And so if we simply standardize by using sub 0.length when we're talking about the number of columns, it's an easy way anytime you're using a rectangular array to get the correct number of columns for any row in the 2D array. So the big one on there, .length for the number of rows, sub 0.length for the number of columns. Big thing to take away from that slide. We also want to talk about the initialization of an array. There's the standard empty initialization. As you can see here on the notes, I have capital T / lowercase t type, because arrays can hold either objects or primitives. So whichever kind of thing you're putting in there, you declare the type. The 2 square brackets empty, so to indicate that it's a 2D array, because again, there's no keyword for array in Java. And then the name of the array, the equal sign or assignment operator, the new keyword, of course, and finally the type again to specify again that we're making an array of that type, followed by first set of square brackets filled in with the number of rows that you're going to put in that 2D array, and the second set of square brackets to indicate the number of columns in that array. It is very important you specify both the number of rows and the number of columns at this point. If you do not specify the number of rows, it won't compile. And if you don't specify the number of columns, you leave yourself open to the idea of having a sparse array accidentally. Secondly, when initializing an array, we can do what's called the prefilled initialization. Now that we talked about the hipster arrays, we saw that there's the extra hipster way of doing arrays, where we know all the values in advance. We can also do that with a 2D array. And so in that, we do type, 2D array, indicating that it's a 2D array. Array name, still the same, just like that. But instead of using new, we use what's called an initialization string, or initialization list, where we have a set of squiggles. And then for each array, it has its own set of squiggles with comma separated values. In this case, I have variable / values, comma, separated, comma, by, comma, in squiggle for the first row. The second row of that array is each, comma, row, comma, endorsed, comma, enclosed, comma, in squiggle for second row. Third row, its, comma, own, comma, set of, comma, squiggles, close squiggle, close squiggle. This indicates that we are creating, right here, a 2D array that has 3 rows because we have 3 sets of squiggled chunks. It has 4 columns in each row because we have 1, 2, 3, 4 values in the first one, 1, 2, 3, 4 values in the second, and 1, 2, 3, 4 in the third. So I've created a 3x4 array because it has 3 rows, 4 columns, and I initialize that right here with that, assuming that variables / values, etc. are all individual objects in that array. And so this is something you will see when we're initializing arrays from pre-existing values. So if you already have values that you know need to be stored, this is the way to store them in a 2D array. If you don't know the values that you're going to be putting into it, you'll generally use the previous mention, which puts it together as an empty array, which means it will be filled either with, if it's an int, zeros, a double, 0.0, a boolean, falses, or any object, it's going to be filled with null. So you have to remember that when you first initialize an array, nothing's in it, unless you use the prefilled method where you pre-assign all the values. And we always want to avoid our good friend, the null pointer exception. The next thing we want to talk about is how to assign to arrays. So if you haven't done at the beginning, the 2D array is filled with the default type of that value, where it's 0, false, and null, like we just talked about. Generally, when you're assigning values into an array, you're using a set of nested for loops. There are other ways, of course, to initialize values inside the array. You can do it manually, one at a time, without a loop. That might get to be, well, very painstaking and boring, but that is doable. But generally it's going to be done like that. And the structure inside a set of loops would be that line right there where array name sub row sub call equals whatever value is to be assigned to that cell. So you take the name of the array, you specify what row and column you wish to put that value at, and then use the equal sign, aka the assignment operator, and the value you're actually putting in there. Because again, arrays have no methods, so all we do is simply shove things in or get a reference out. Let's see an example of that here using a regular for loop to initialize a 2D array. We have a 2D array predefined earlier called myWords. I assign it as a new string array that has 14 rows and 23 columns. I use a nested for loop structure right here where I initialize from row 0 up to words.length because that gives us the number of rows, going up by 1 each time. I then, in my interior loop, I have call equals 0 to start the columns off at 0, going to my words sub 0.length because I want to go to number of columns, making sure I address all of those columns. And then inside this, at my words sub row sub call, I assign the value of a string that says the address of the cell is row plus the row number, call plus the column number. So we can actually keep track of the values of that as the actual string value of the cell. I use this right here with a regular for loop, so you can see the idea that with a regular for loop, you have specific access to the actual position of every single cell you're talking to, because you have access to every row and column that are attached to that. So if you want to go for specific cells to assign specific values into specific positions, you need to use the regular, everyday for loop going from 0 to length, 0 to sub 0.length. So that's the standard process for initializing with a for loop. The same thing would be if you wanted to replace values. Obviously, initializing and replacing, same basic approach. We have the for each loop is a different way of doing it, however. As you can see right here, I've said simple values is a new int array of 12,355 rows and 24,335 columns. Huge. And I'm going to say that for every int array that's called number row, inside some values, so for every row that's in there, I'm then going to go for every value inside that row. I'm going to say that the value will be assigned something that's an int of math.random times 1, 2, 3, 4, 5. So I'm just going to say it's some random number somewhere between 0 and 1, 2, 3, 4 is going to get shoved into value. Now I specifically chose the idea of using a random number on this and a for each loop, because with a for each loop, we have no reference anywhere in here, as you can see, to which row or column I am talking about. It just says for every row in the 2D array. It does not say what order those rows will be processed, nor is there any guarantee what order those will be processed. If I look at that second one, for every int value in that number row, again, there is no specification of which direction I'm going, whether I'm going up, going down, up, down, left, right at the same time. There's no specific direction or approach to that, because when you're using a for each loop, you have no reference in that loop to its position or its location inside that 2D array or 1D array. We also need to note that when we're using a 2D array, that the outer loop must always be rows. We could do an outer loop on a regular for loop with columns, no problem, as long as we specify columns as that second parameter and do sub0.length. But with a for each loop, the only way to do a for each loop is using rows, because we have to grab each row out of the 2D array, because again, an array is an array of arrays. So a couple things on that. You want to make sure we identify that a for each loop has no sense of position or order, and that's why I'm using that random number as a further cue for you that the for each loop has no sense of where it is as it attaches itself. It simply does it to all of them. So I can initialize with a for each loop. The only thing is, if I initialize the for each loop, it's all going to be the same. Or in this case, it's all going to be some random number. But I can't guarantee anything about where those values are. If I care about the where, I have to use a regular for loop. So let's talk about accessing the contents. We often need to retrieve values out of a 2D array. The way we retrieve values out of arrays is just like retrieving them out of a 1D array, where we have some variable on the left-hand side of an equal sign that is assigned the value of what is at that location in the 2D array. In this case, it's array name, sub row, sub call, gets shoved into variable of type stored in the array. Again, you can't reassign this into 7. You have to actually use a variable for that. This is most often done in a nested for loop. For some weird, bizarre reason, you generally need to actually specify more than one time you're trying to get a specific value out. There are a couple occasions where you might only want one value out of a 2D array, and so you would see a line like this simply on its own with some specific row or column variable or value attached to it. But 90% of the time, this is done inside a nested set of for loops. If you need a specific value, again, like I said, you need to make sure you use the standard for loop, because you'll have access to the row and column variables where you can specify which row and column you're talking about. If you're just grabbing every value out of the 2D array, regardless of where it's coming from, then it's okay to use the for each loop, also known as the enhanced for loop, also called the enchanted loop. So let's take a look at that in code right here. Our for loop access, I'm now going to look at that original version of the int array, the one that we did randomly. We can still access one that we used a for each loop with a regular for loop, which is what I'm doing here. In this case, I'm starting off at row 0, going up to rows.length, some values.length, row plus plus. Start at column 0, go to sub 0.length to get the number of columns. And then for every spot in this huge, ridiculous, randomly filled array, I'll do a J-option pane show message dialog, where I'm going to pop up the value stored at row, call, is whatever random number is shoved in there. So I can traverse an array that I created with a for each loop with a for loop, because it still does have that row column structure. It's just when I use a for each loop, I have no reference to it. But when I come back into it later on with a for loop, I can access that row and column information without a problem. And so the for loop access on a previous one, I can get access. This would be a ridiculous thing to do because no one wants to watch that few million versions of pop-ups. But the idea right here that we can use a for loop and find specific row and columns even if we hadn't used a for loop before. And finally, we'll use the for each loop access to retrieve all the values out of our string array. And for every string word row, string array, in my words, I'm going to go then for every string that's in word row, and I'll do a J-option pane show message dialog on that, and say I don't know where this string is, even though the string itself says where it is. So the string will say, oh, I'm at row this, column this, but the for each loop has no reference to that. Again, because a for each loop has no way of seeing what is happening or where it is. A for each loop is just designed to do something to everything. A for loop can be used to do specific things to individual parts. A for each loop is only going to do it to where everything that's in that structure you're dealing with.